My name is Oliver Schuermann. I'm with Juniper Networks. I run all the system engineers for the U.S. commercial space, and I'm also a field advocate for software and automation, whatever that means, right? And we'll kind of cover that today. What I kind of wanted to talk to is software-defined secure networks, which sounds like a great architecture, but I'll hopefully walk you through kind of what that means. My goal in life is not to get through slides. I realize I'm between you guys and lunch, so I'll try to keep it somewhat entertaining and hopefully informative. But we are going to talk about a bunch of different stuff, so kind of sit back, relax. And I'm going to start off with something that has absolutely nothing to do with what I'm going to talk about. And it's about attention and focus. In the year 2000, Microsoft surveyed 2,000 Canadians and found out the average attention span of a human being was about 12 seconds. Fast forward to 2013, we've actually dropped 4 seconds to an attention span of 8 seconds. And this is really due to what we call weapons of mass distraction, whether that's Twitter, whatever your device is on your phone, etc. And that's really caused us to drop focus. There's actually an animal out there that has an attention span longer than the average human being, and that's a goldfish. That's really not attention span. Since I'm an engineer, technically it's their memory, but let's go with that for a minute. But in the next 23 years at current pace, we'll finally, thanks to our wonderful devices, reach what Buddhist monks have wanted us to do for years, which is live in the moment. So really, how often do you check your phone per day or per hour? So here's kind of a survey we did of millennials. And it says you check your phone an average time of 43 times per day. I found out millennials I don't fall in that category, and hopefully this doesn't fall into what we have today, but if a meeting's boring enough, I can check it 43 times per meeting. Here's kind of how many times you look at your phone per week. They say 1,500 times. If you do the math, that works out to 214 times per day, 12.6 times an hour, or every 4.8 minutes. So kind of the point here is that we've kind of, as society, as networks have grown and changed, have utilized these devices and how we look at things. It's our exobrain, if you will, that we look at. We depend on these devices. And hopefully, I won't miss the mark on this presentation, but here's some statistics. In the last minute and a half, which is about what those slides take, here's what's happened. 204 million emails have been sent. Here's all the YouTube downloads, etc. And these are stats that we're pretty comfortable with. What's scary is if you look at how many new malware infections were put out per day, what the cost per breach is, and all these things, this is becoming normal. I think about a week ago, we had a report on the healthcare.gov website was hacked and there was records stolen. Nobody really reacted to that, but it's becoming commonplace. And it's an interesting world we're living in now to where we kind of expect that. So it's not really a if, it's a when. Some of the complexities are that as a C-level executive in an IT firm, you have a very short period of time to determine whether you're on attack and how to react. And here it says every 7 minutes, but this is some countries in Europe, and I'm a big proponent of 65% of statistics are made up on the fly, but it's a very short period of time. The challenge is what we call signal-to-noise ratio. The more things we put into the network, the more data we get, the more logs we have, the more things we have to make a decision off of, and it's exponentially challenging. How do I react? What's my business impact? It's becoming increasingly difficult, too, with virtualization. We've had virtualization on servers and things for a long time, but now the network's starting to follow suit. We have shadow IT, meaning all the different cloud services that are out there. If I don't like what's in my network, I'll go buy something else. We're looking at what increases as far as cost-wise, but it's not really the cost that's increasing. It's also a business now. It used to be, back in the 90s, it was script kiddies, can I go deface a website? But now there's actually a business. There's agile development, there's project timelines, all in the hacking community. And it's quite interesting what's happening these days. We, as a IT community, think the fastest way to solve a problem is to keep doing what we've always been doing. Add more services, add more, the security component de jour, and not change the paradigm of how we're looking at things. And the way we address that is we keep pouring more money into security, meaning that we add something else to the perimeter, we add another, service, we add another detection mechanism, we add another component. And it's like home security. We know that all the things are already inside your network, but we're adding more cameras, more locks, more sensors to the front door. If I think back 10 years ago, and I've been with Juniper for a long time, we were selling an SSL VPN product, and the key there was we assumed that when somebody was on premise, they could be trusted. They had a corporate laptop, they were in proximity, but when they left proximity and went to a Starbucks, perhaps in like the medical profession, they had different access. Or if they weren't in compliance with what we were doing, we were able to cut them off, single user. But now we look at things at the perimeter and we assume that's an alarm system, that's good enough. When you look at where attacks are coming from, they're from inside our network. What's happened between the time where we're issuing corporate laptops and now, and I know it's not a surprise to anyone, is BYOD. But we haven't really thought about what that means, or we have, but we assume that we can't deal with it, and we can. Also, we look at risks as far as what they'll cost us to mitigate, as opposed to the cost of the business outcome. I spent 26 months in the education vertical. And if you look at what business outcomes mean there, in K-12, for instance, it means common criteria requires that you bring some kind of learning experience. But what most CISOs look at from an attack perspective is, if my network gets attacked, if I get hacked, it's going to cost me, average of $15 to $20 million. Because I have to now get everybody credit protection. If I'm in a PCI compliant environment, I have to make sure all those records get pulled back in, et cetera, and there's cost to it and fines. But what I don't look at is I shut down that learning for a day maybe. I have to now cut myself off the internet, and now I'm essentially having an internet snow day. But I'm not delivering the services I want. Retail is a great example as well, especially like an e-tailer. If your network goes down, you can count by the second how much money you're losing, right? So those are the things we look at. And due to the business fact, attackers are always gaining. So we continue to do the trust model. Everything that's inside is secure. Everything that's outside is not. So we keep putting perimeter firewalls in place. Or with command and control traffic and the way things are being hacked, we'll look at it from a alarm system perspective. Somebody went out and tried to push some data out. Maybe we stopped it. Maybe we didn't. Maybe your IPS picked it up. And it's just becoming more complex. Now, server-side folks use orchestration and automation and have been for a long time. Set up systems to build systems. Attackers certainly do it because the cost of an attack, we've all looked at, and we're all security guys, I think, here, and we have looked at the way an attack is built, right, from scripting to finding vulnerabilities to then executing, etc. But shouldn't your network use automation to really thwart attacks? And I'm going to take a step back, and I had to use that, but I couldn't resist putting the Back to the Future DeLorean in the slide. But I want to talk about the network from the ground up, meaning not just from a how can I use it to help better detect, but what are the problems that we have today that we haven't really addressed yet? Talk about deployments, and I'll talk about integration, this little thing we call DevOps, and then kind of some architectures and kind of an open software stack. And I'll definitely try to keep that from a Juniper commercial, although I will have to put a little bit in there. This is a really old slide. If you notice, there's dates on there from 2001. Problem is, the old slide, the old statistics, these things haven't been addressed. It talks about consistency and human error in networks, or in software even, that downtime is caused by misconfigurations. Vulnerabilities are caused by misconfigurations. In fact, we did a study in 2013 of academic institutions that think they had vulnerabilities due to misconfigurations. And it was 75%. And I think that number varies depending on the industry, depending on what you do. But if you look at what those things are, they're simple things. SNMP strings, inconsistent VLANs, inconsistent passwords. And it's interesting how much this still exists. And now it's becoming even more and more critical. If I can hijack your switch or router and put a VPN tunnel to wherever and start to suck up all your traffic and put it into my system and start to analyze that, that's a big problem. And it's really not that hard to do. We do have an opportunity to look at this and look at it from a templating point of view. I intentionally put up the tool that we most use for templating, which is the high-tech tool called Notepad. It runs on Windows or whatever system you happen to use, or VI, if you're a Linux guy or BSD guy. But I intentionally put the curly brackets replacement in here because there's a programmable way to solve this problem. If you ever heard of a language called Python, it works with a templating language called Jinja 2. And I won't go down too far into the weeds, but we can use these two files, put them together programmatically, and we're able to build consistent configurations. Not that the things of the past of Notepad and Excel haven't worked for us, but end of the day, you've sat there and done this before. You've Control-C, Control-V, Control-C, Control-V. After about 10 times, the lizard brain in the human body kicks in, and we go, okay, now I'm starting to listen to the song over here, the phone's rang, and I'm getting distracted, and oh, I'm now 10 lines into it, and now I've made an error. This is how these things happen. Programmatically, we can put those in a database, and this is an eye chart. It's not meant to be read. I don't even know what half these slides say. I'm kidding. But we can actually take these and deposit these and actually use them for deployment. The old way we used to deploy equipment, or in some cases still do, is when we receive equipment. This is where you can tell I'm not in marketing because this slide animation is terrible, but we pull the equipment out of we receive the equipment, we look at it, figure out what it is, we put a configuration on it, we put it back in the package, and then we ship it off or we rack it. The problem with that is it costs time. And usually I'm up here pitching ROI on what it would cost you from a time perspective. It's easy math. It's this much time times cost of labor, etc. But also from a consistency perspective, we miss the mark a lot of times. These configurations are a challenge. And if we use zero-touch provisioning, which is not new, we used to call it boot P back in the 80s, or Pixie boot, depending on how long you've been in the industry. We can put files on devices just by booting up. We do it with phones, we do this with POS terminals, we do this with all kinds of different things. This is not new. And you can save a significant amount of errors and a significant amount of financial just deploying this way. And where this started and where this relates to security, because I'll bring it back. I don't know if everybody saw the movie Clerks, but I couldn't resist putting the slide in. We started off with a retail establishment that wanted to deploy 7,000 firewalls to their locations, didn't want to stage them, didn't want to do truck rolls, and wanted their store managers to configure and install these devices in a PCI-compliant environment. Scary, right? Utilizing this and some of the things that are available now as we get more integrated with DevOps and programming and such, is intelligent provisioning where I can do things like figure out where I am, perhaps what store I'm in, IP address, what have you, and do intelligent things. So that's how we were able to deploy these devices. And this was handled by 3 network technicians. But past just deploying equipment, the next challenge, we talked about virtualization and why is security so hard today, because we fall under the services shadow paradigm, if you will, which means that perhaps my network or my security policies don't follow me around as I migrate things between data centers, between racks. Integrating with these tools, we can do that. But sometimes, like we talked about earlier, it's a challenge to kind of break the old habits. It's easier just to go manually configure stuff than spend the time to solve these problems. And really what you want to look for is an operating system or a vendor that can support all these different things. There's a lot of DevOps vendors that are, or network vendors that are moving to a DevOps model. And it really comes down to, how flexible am I? How many things can I integrate with? Here's an example of a whole bunch of programming languages, which is good news, which is, we have a lot of things that we can configure, we can do, we can build, we can integrate into various systems. Things that tend to gravitate towards networking folks is Python, so there seems to be a common language there. And there's lots of open source libraries that exist that support Juniper and other vendors for ease of integration. But let's take a quick walk into the weeds a little bit, because I'm going to double click and kind of talk about what an open network stack should look like. And the reason I bring this up is we started off talking about provisioning, we talked about automation and those kinds of things. But how does that tie into the title of this thing, which was Software-Defined Secure Networks? And what I'm trying to illustrate is that there's a certain integration you can do and a certain benefit you can get from an open operating system, from an open vendor that's integrating with things today that allow you to make a stronger security stance than just looking at the perimeter. And I took a lot of the Juniper stuff out of this, but this is modeled on our software stack. But the point is from bottom to top, you have the ability to program open architectures for things like an XML RPC, or even industry standard things like netconf, to where I can control devices which are vendor A, B, C, or J, and make configuration changes on the fly so I can react. Moving a little further up the stack, I've also got integration with the DevOps tools that we talked about earlier, like Ansible, Salt, Puppet, Chef. And this helps in the maintenance process, meaning when I move things around, or when I start to change configurations, etc., I can have my policies and things orchestrate to follow that. This helps me create consistency. This helps me move services around as they're within my network. And you also have tool makers, right? You want to be able to either integrate with things you have today, or you want to be able to have other vendors that can easily integrate with that. That's if you look at the whole. I hate to use the acronym SDN, three-letter acronym, but that's really where everything is going. We're kind of abstracting what it means from a management platform, and we're allowing to create customizable kind of Lego bolt-together solutions that will help us and develop these things. Of course, in those software stacks, the further you leave the chip level, which is at the bottom, and the more complexity you add, so the simplicity goes away, and the further on you go down, we'll add flexibility. Here's the only slide that has our CEO in it, I promise. But one of the biggest things that's changing, no matter where you look or what you read, and this not only applies to networking, is automation. The things are changing to where we're able to take tasks that are overwhelming at this point, and we're able to reduce those. Think about the log records I talked about earlier. It's not really, and a lot of folks, when they talk about automation, they think back and they say it's about cost reduction, it's about eliminating components out of the network. It's not true. The biggest thing we're trying to do is keep up with things that are there. Log generation, the explosion of devices, the explosion of things in your network is increasing complexity exponentially every day. So this double clicks into more orchestration. Automation is automating a single task programmatically using a programming language, looking at a workflow. Orchestration is to be able to look at this at a holistic level and make things on a larger scale. And it should be vendor agnostic. It shouldn't matter whether it's, I'll use the server side because I don't work for a server company, but whether it's Linux, Microsoft, Apple, it shouldn't matter. right? When I'm making a change to the software side, that's what it's been like for years. I don't care. I want to stand up a LAMP server. So that's how orchestration should function in a network. We also need to change our mindset about security. Threats are everywhere. We know that, but we don't react to that quite as well as we should, I don't think. We still look at things from a perimeter level, which we talked about earlier. Detection and enforcement should be everywhere. And we should be able to use every component in the network as sensors. If you think about IoT, that's what we're doing with all the different things we're plugging into walls and cars and everything else. Why shouldn't the network be the same way? Good example of IoT, and I like this example, is it really makes you think. And it really gives you a great example of the quantity of things we're going to see. We talk about the Internet of Things all the time, and we never really take a step back to think about what that is. But BYOD was a huge thing for us. Now we've got the Internet of Things. But if you think about what those things are and how simple that can be, a light bulb. Light bulbs have chips on them now that run Linux that do things like turn themselves on and off. We've seen the ones at your favorite hardware store that change color, can beat to music. Those are wirelessly connected. And I bet you the vendors that create those don't really think of it from a, let's make sure this is really secure. The Ring doorbell is a great example where I could just pull it off somebody's house and their Wi-Fi password was in clear text on the chip. So as long as they didn't lose electrical polarity, I could pull it off. But think of how many light bulbs are in this room. And think about building and exponentially, you talk about thermostats and all those components. You need to be able to look at those, and I don't think that we're going to be manually writing policies that say, okay, the Philips light bulb that I plugged into this entire floor has this type of traffic behavior, should only do, should only turn itself on and off and send statistics on a slow level. It should be able to be dynamic, and if that starts to be out of characteristic of how it normally behaves, we should be able to detect that and shut it down at the port level, not at the perimeter. I still think it's an interesting paradigm that I can hack a light bulb to get to information, but I don't think it's out of the realm of possibilities. And if you look at normal firewalls, we have the first generation firewalls, and then we have what we call the next generation firewall, which is not so next generation anymore. It's been around since 2011. So, but we have these services that we look at, stateful layer 3 type services. We look at intrusion prevention, user-based firewalls to see who's doing what. We use antivirus, we use intrusion prevention, we use all these signature bases to take a look at this stuff. We look at it, again, on a perimeter level. Also, something to take in consideration is that we need to look at things on a paradigm perspective. For instance, your campus network has users. Those users do things and they get information from outside. Your data center is quite the opposite. It has users on the outside, in theory, and they're getting information on the inside. Unless you have a bigger problem, then that's another conversation. And then, of course, branches and service providers, those are all different paradigms. So how do you take that into consideration when creating the policy for the light bulb? So policy creation should be simple. If you think about the earlier example, it's about location, it's about risk level, it's about what equipment should be there, how it should be reacting. But I should be able to write one policy that covers everything. So that defines that data definition language that we talk about, that should make it simple. So we use on the server side to say, I need to stand up a LAMP stack and don't care what it is. Detection, I should be able to detect from multiple sources. It shouldn't be pinned into a vendor, as much as it pains me to say that. I should be able to take things like, I think about a year and a half ago, Facebook came out with a free phishing feed. I should be able to look at things from a vertical market perspective, meaning that, like for instance, vendors look at things in a vertical market and say, okay, I'm going to build messaging for education, for retail, for whatever. Attackers look, because it's a business, look at things the same way. They're going to say, they're open the phone book, whatever those are, right? But they're going to categorize things by a vertical. Say it's banking. And they're going to try the same thing over and over again until they find the path of least resistance, and then they'll start stack ranking their attack points. But what if you shared information amongst your industry, whatever that is, either through a third party like a partner, or perhaps it's even internal, like academia spends a lot of time sharing information. Retail, not so much, because they have secret sauces and they hope their friends get hacked. But if you're able to share that amongst the community, you're able to install that and hopefully install that without any fee to your security solution. And then, of course, there's third-party feeds you can buy as well. And then also, we need to be able to enforce that and not just enforce that at the perimeter. Because as pervasive as things are getting, if I'm able to get root on your device, server, laptop, light bulb, I'm going to try to get information out of your network. And I'm going to go for the first path first. But as we know, there's multiple exit points out of a network, especially as folks bring rogue toys to class, if you will. So I kind of sanitize this, but this is some of the stuff that we do, but I think other vendors do as well. But I think we do it better. And if you want to learn more, stop by the booth today. But one thing is looking at it from the entire network perspective, being able to look at and leverage your entire network for detection and for enforcement. The paradigm of any attack requires it to go over a network at some point in time, so the network logically is in the best position to defend for that attack and detect it. Also, from a compute perspective, some of the things that we do in security, particularly as we remember the days where we started to implement IDS or IPS, the processing power required to do some of that, sometimes it's challenging. So as we get into newer paradigms, we should use cloud resources to offload some of that processing and things that aren't quite as sensitive. If you think about the paradigm of just to step out of security for a second, and just from a processing perspective, you think about how the new Xbox is architected. All the things that aren't so time sensitive from a gaming perspective are offloaded to the cloud, curtain movements, stuff like that, right? So why wouldn't you do that in security? And with the way networks have evolved today, the way processing has evolved today, the difference is not as big as it used to be. So being able to process that is interesting. And then have a dynamic and adaptive policy engine, meaning something that can interpret what I'm trying to do and interpret it on a larger layer, be able to talk to devices that are perhaps one vendors or perhaps multi-vendors. So there's a cloud. Oh, it's built itself. Automation. The cloud offload I talked about, looking at it from a firewall, from a routing, from a switching perspective, which are all the three products we happen to sell, but also looking at it from a third-party element perspective. In the case in point earlier of the light bulb, it's connected to an access point. If that access point doesn't speak the language of that vendor or that open architecture, then I can't just shut down a single user. Now I'm shutting down a single access point. That might not be as good. All your lights might turn off or whatever, right? But what you want to look for in a vendor is to make sure they're using an open architecture to where we can talk to different components. That's what'll make this work. Otherwise, you're still kind of stuck in the same place you were before. And then, of course, the security policy controller. If you look at the paradigm of SDN and what we can do with microsegmentation and all the different things that we're creating there, we now have the ability to utilize those controllers in a security paradigm. From a OpenStack perspective, Juniper is just named the number one SDN-friendly vendor, whatever that means, right? But it means that we have an open architecture that'll work with everybody else. If you look at some of the competition, they have proprietary controllers or proprietary protocols they use. We use bleeding edge protocols like GRE and BGP to do our controlling to move things around networks. So we'll play with any equipment, right? So that's important as you consider this, because otherwise you're locking yourself back into some paradigm of some story somebody else told you. This will let you go in any direction you'd like. But moving to the previous slide, that's a lot of work. I'm going back to the paradigm earlier that it's easier to continue doing what you're doing than making a change and moving to that model. you have to look at this in steps. So what do you do first? You look at your perimeters, you look at refreshes, you consider things that we talked about today from an open standards perspective. You look at that from a virtual systems or virtual firewall perspective for services. You look at what kind of cloud security do you want to look at. And there's a lot of choices out there. A lot of vendors have those products. And how do those integrate? Are they open standards? Will they integrate with other vendors as I make other choices? And then converse with your network. Be sure that you can use the network elements that gather data to have those conversations. And then also make sure that bolts in with other network elements, whether it's your access points, load balancers, etc. So going back to the light bulb model, my light bulb's now gone rogue. I can correct this behavior by shutting down the switch port it's plugged into. I can mitigate this behavior by putting it in a quarantine. I can examine it. I can take those payloads and put them into the cloud and process, see what they do. There's lots of different things I can handle. But worse, the compromised switch. I've now created a simple IPsec or GRE tunnel down to my lab layer and my evil whatever. And I'm now spanning a port and getting all the information off your network, and some's useful, some's not. But in the paradigm we're in today, we'd probably end up cutting access off of that entire switch. If you can talk to that switch with some kind of control protocol, I can shut down that port, or I can just shut down that tunnel. Simpler. So, here's what I think you should look for in a vendor. Scale is obviously important, right? Anything from the small campus networks to branch networks to high-end networks, it should have the same paradigm, should be easy to configure. Scale is a challenge. A lot of vendors start in the SMB market and work their way up into the carrier market. Kind of the opposite of how we do things, but the challenge with there is creating that scale. If you solve the hard problem and solve it once, it's easier to create that scale down. Open standards are important. If you look at the market today, a lot of vendors can't pivot to open models because it breaks them from a financial perspective if you think about it from a business side. Some vendors don't want to. Some vendors have talked about hardware-defined networking. Some vendors won't disaggregate software. These are all things to think about. And the automation side, how truly open is that? Do you have to pay to automate? Do you have to buy their SDK? Or is it just open? Does everybody work with it? How much open source exists out of it? These are all things to think about. As I was told in the back, I'm down to 4 minutes, so that's all the time I've had today. I threw my Twitter handle up there if anybody wants to follow me on Twitter. Occasionally I'll say something witty or something intelligent. It really depends on the day. But I certainly thank you for your time. I'll be floating around at lunch, and I'll also be in the booth. If there's any questions, I'll be up here for a few minutes as well. Thank you very much.